Hello, Alex Cole here from BobCAD-CAM. So what we've got this time is a more advanced part. This is actually a port looking part. It's an example that I put together, just something that illustrates tracking a 5-axis toolpath deep down into a port type cavity and a lot of the common things that people run into and how to control certain aspects of machining for this. So I've got my geometry and certain things on different levels here. So let's go ahead and get started with this toolpath. So I'm going to start by turning my surfaces off at the moment, and you can see that I've got wireframe geometry created for my boundary areas on a different layer. This is just organization to make it easier when I'm selecting geometry and so on. So we're going to follow the same recommended procedure of starting simple and getting a pattern down on that set of surfaces first, and then we're going to continue to refine the tool path until we get the final end result that we want, which is a nice clean cut on this port tool path. So for this tool path, I'm going to use morph between two curves, and for my tool, I'm going to go set up a lollipop tool. I'll grab one that's close from the library. This one's going to be a 375 diameter. We're going to do a 1.5 protrusion length. Let's set up our comment so that it's accurate to what we're using. Okay, and we'll get into the parameters. So for this toolpath, we're using morph between two curves. So my first curve is going to be this upper edge at the top surface, the large portion of the port. And the second curve is going to be the opposite end of the port. And this port we'll see is actually going to be quite deep, so I don't want to machine the whole thing, but I'm going to show you, even though we're selecting the port all the way at the end for that second curve, we're going to be able to limit that toolpath back, and we'll get to that later in the video. For my drive surfaces, I can now turn on my layer that has my surfaces and select my two drive surfaces that represent all of the port. And what I'm going to do to keep the calculation times quick, I'm going to give us a 5/1000 tolerance and a larger step over, just so that we can keep calculation times very quick for the video. So that's going to be my first set of changes, and now I'm going to compute this path and see what it looks like. So with that path computed, for those of you that are wondering, I'm pressing the T key on the keyboard, which makes the surfaces transparent. This way I can get a representation of the part, but at the same time I can see my tool path. So looking at the tool path right now, what I'm seeing doesn't look too bad. Overall, looking at this pattern, that's what I'm focusing on. However, we can clearly see that the way that it's linking isn't desirable. We're going to want to convert that to a spiral. We're going to do that later. Right now, just focusing on the raw path. So this raw path looks pretty good. So let's go to the next step, and that's going to be implementing the tilting strategy to get the tool tilted the way that we want. So let's edit this feature again and go back into the parameters. And on the tool axis control page, I want to use the tilt through curve option. And we've covered this in some other videos. If you haven't seen them, you can check them out. But the tilt through curve option is pretty powerful, and the way that we used it before was just angle through curve. That's the default method. But for this particular machining operation, I have a curve on another layer. Let's go ahead and we'll select this tilt curve, and that way you can get an idea of what it looks like. So I have this line that's out here in space above my part, And what this line is representing is I want the tool, as it's cutting the mouth, the large mouth portion, I want it to be using this end of that curve to constrain the tool. But then as the tool works deeper and deeper into this port, it's going to transition along this line to where, as it's finally at the deepest portion, it will be at the end of this curve, and that's going to give us nice control over that tool and do exactly what we want it to. Now again, the placement and the length and size of this line is just something that you'll have to evaluate and determine where it should be, how far away from the part it should be, because again, that's all going to determine, the tool will run through a location on that line and then down to where it is on the surface. So this curve tilt type, what I want to do is I want to switch this to the option from start to end. And what you can actually see is this is an option that's specifically designed for doing port type features. And so as the tool is cutting at the top, it starts at the line, but as that tool path continues on, it traverses down through that tilt curve that you've defined for the end of the tool path. So that's exactly what we're wanting in this case. So let's go ahead and compute that and see what the results are. Okay, so we have that computed now, and with this computed, let's go ahead and backplot and get an idea of what we're looking at. So let me actually snap right to a front view, and as this steps through, we can see the tool is tilting right through that line that we've defined, and it starts working its way around the mouth of that port type shape, and that's working exactly the way we want it to. And if we continue through, we can see the tool is actually traversing down that tilt curve as the tool is working on the path. And it will continue to do so, traversing down through that line, which in this case is laying that tool over more and more as the tool path continues, which is exactly what we need it to do so that we can continue to maintain clearance. Now, there's a couple things that this has caused with our tool path, and I want to point this out because this is a common hang-up with customers that are trying to work on these parts. So if we look in this section here where the tool is right now, if I back this up a couple steps, we can see there's a little jog there where the tool actually backs up, and we can see it in the path right here along these edges. Okay, and that's something that we don't want, but we're going to deal with these one step at a time. We actually have a good tool path on here. The angle of the tool is looking good, and as it works its way down, that tool is laying over exactly like we want it to. So let's deal with and look at what is causing these little jagged moves that we see right here on each of these passes. So in the parameters of the multi-axis tool paths, the surface-based paths, on the surface paths page, we have this advanced button. And in this advanced button, there is this option for the pattern creation. So this is what's determining that pattern that's getting created on the surface based on the options that we've chosen. Well, the step over calculation method defaults to a method called approximate. And in a lot of cases, that works very well, and it is a fast calculation. However, it doesn't work in all scenarios. So we can actually change that to an exact method. And let's see what the result is once we convert that over to use an exact calculation for that step over. Okay, so that toolpath calculation is done, and we can actually see that those moves have been eliminated from the path, and we now have a smooth transition, which is exactly what we need. So we've taken that next step and we've gotten a now clean path with our tool laying over the way that we need it to. And we can start to think about what is the next obstacle that we need to be able to create this good final path. And so we can see, I'm going to back plot this through, and you can see there's no longer any of those funny little jog moves that we were experiencing earlier as it transitions up the side of that port wall. Okay, so what is going to be the next obstacle that we run into? If I go to a front view and I continue this path along, we can see that this tool is eventually, though it is a long tool, we're eventually going to start having problems here with the shaft of our ball and our lollipop tool, excuse me. So as this thing steps along and continues, we can see that we're now starting to rub the shank on the part. So what we need to do is we actually need to restrict this toolpath back. We need to not do so many passes. There's no need for us. We have a 5-axis machine. I can machine part of that port from one direction and then machine the rest of it from the other direction. And there's a way that you can do that without having to create new geometry or different slices and curves. So let's go back into the parameters of this path. And let's talk about some of the options that affect this. So on the Surface Paths page, the Area group has a type field where we can pick several options. There's an option Full, Avoid Cuts on Exact Edges. We have Full, Start and End at Exact Surface Edges, and we have Determined by Number of Cuts. Now, Determined by Number of Cuts is one that I use frequently because it allows us to define the specific number of passes that we want to have the system generate between the first profile and the second profile that we defined up here for our curves. So when doing port machining, it's often desirable to leave a heavy scallop so that it can disrupt the airflow and so on. I'm not a race car designer guy, but I know that a lot of people prefer having that heavy scallop in there. Or if you would want a super fine scallop, what you can do is you can define the specific number of passes for it to make. And it's not calculated off of an exact step over. So that one is actually a pretty useful option, and I personally use it quite often. That option, as well as Start and End at Exact Surface Edges, gives you this margins option that you can select. Now, in the margin, we have start margins and end margins. And in this example, we want to put a 1/2-inch end margin because the end of the port that we want to shorten the toolpath up, that was based on that where we selected that second chain or the second curve that we defined. So I'm going to put 1/2 inch in the end margin, and we'll see that that should back up our toolpath by a 1/2 inch from the ending that we were seeing earlier. And we can see that now this is retracted back, and when we back plot this and we advance up to that end, we can see that tool is now stopping. So I haven't had to change any geometry, I haven't had to modify anything to be able to control the end of that tool path, and now I can then make a second operation to come in from the other side to machine the material that's left. Okay. But looking at this, I do see a problem. We have a retract that is coming back and it's clipping right here. So we're not quite going as far as we need to. So let's go to our linking page and we're going to look at some of the important options on that linking page. Okay, so on our linking page, we have an option here for an entry and exit. When working with a tubular shape, there is an exit strategy specifically designed for tube shapes, and that's this retract to clearance area through tube center. This is designed for a port, and what it'll do is bring that tool up through the center of that port based on their calculations and give us a nice clean exit where we're not going to hit that tool on something. So that's the first thing that we want to set. The next thing that we need to define is we need to define that retract to be long enough from the end of our toolpath to actually get that tool out of the tube before it goes up to our clearance plane. So if I select the retracts option and go into this retracts parameter page, we can see that we default the rapid distance to about 800 thousandths. I'm going to open this up to about 2.5 inches, and that should give us plenty of pullback to get that tool up and out of the way. So let's compute this toolpath and see what we have. Okay, and so we can now see that line running up the center of the tube, right down the center, and then the tool comes out. So that's perfect. That brings our tool right where we want it. So we can go ahead and start moving to the next part of getting this programmed. So the next thing that I want to do, right now this is cutting in a circle and then it's plunging down or moving to the next slice and continues that throughout this path. If I was really cutting this, I would want it to maintain that cut, stay in the cut, and so I will simply come in and go back to the parameters, and on that first surface paths page under our sorting group there is the cutting method, and we can set the cutting method to spiral. Now, why didn't I do that when we were first defining the cut path? The reason that I didn't is because using the spiral method takes a lot more toolpath calculation time to get the system to generate that path. So while I'm working out all of the details on what my tool axis tilting strategy is going to be, what my gouge check or linking is going to be, I don't want to have that extra toolpath calculation time while I'm working out those details. So I typically leave the spiral option set to as the last thing that I do, and that way I'm not, as I'm working out those other issues that need to be resolved, I'm not waiting on that increased toolpath calculation time. So that is done calculating, and if I come in here and I look, I now have a very clean spiral motion toolpath that is going to cut this port, and that tool is going to engage the material, and it's going to stay engaged all the way around until it finishes this port, and everything is very controlled, everything is exactly the way that I need it to, and we've got a great looking toolpath. So those are just some of the details that I use when I'm working on port style toolpaths. We have to maintain that step over. We have to make sure that we're using a tilting strategy that's going to allow me to manipulate that tool over the duration of a path. And then we can trim that path the way that we need. And then with our linking, we want to make sure that we're entering the appropriate retract method and setting that clearance value so that it backs out far enough.